Hello and welcome to this video where we're going to go over the arithmetic mean and all of the things that we can do with the arithmetic mean. There are very interesting things that we are going to be doing here. So let's start with the beginning and let's start with some notation things that we need to clarify. If we have a data that we call it x, like in this case, we're going to use over bar x here to refer to the arithmetic mean of x. Like what analogously, if the data is y, then we will have over bar y and so on and so on. And when we have data that is ungrouped, that is just said separately, then we can say that the mean is calculated by the sum of all the values of x divided over the amount of data that we have in total. And if the data is grouped, we're going to be doing the sum of x times f, that is each value multiplied times the frequency divided over the sum of the frequencies. I'm using this sum notation not in the most precise way, just as a reference to all of you. If you look at some more videos on or some more books on mathematics, you may see other symbols that may complement this, but I believe that this is good enough for us to start working on these exercises. So let's begin by the top. We're going to have this first exercise. It's a very simple exercise for us to begin with that tells you that we have 5 laborers. They have a mean mass of 70.2 kilograms and they want to reach the top of a building in a lift carrying some cement, and we are going to find the greatest mass of the cement that they can take, knowing the maximum allowance of the lift. So let's start by the beginning. We are told that the mean, let's say that the mass is going to be x. So we are told that the mean of x is 70.2 and we have 5 levers, so n is going to be 5. Then from this we can say that, well, the mean of x is the sum of the values of x divided over n. So in this case we can say that the sum of x is going to be equal to the mean times n. The mean is 7.2 and n is 5, so then this operation is going to give us 351 kilograms. This total, that we call it the sum of totals, this sum of totals is very useful because we know that if all of the laborers are inside the lift, then their masses combined is 351 kilograms. So we know that their maximum is 500, and we subtract the 500 and 351 kilograms for the laborers, and we get a total of 149 kilograms. This is the maximum that they can carry with them if all 5 are there. Now, clearly, if one of the laborers is not there, then they can carry more cement. So this is like how to go with this, is how to use the sum of totals as part of an exercise. So this is like the beginning for this topic. Next, we're going to see another thing that I mentioned, and I believe that it's important for you for us to have like clearly. That is, how can we do this when we're working with data that is given in a frequency table? And if you think about it, this means that we have 31, the value 31 repeated 5 times, then we have the value 32 repeated 7 times, and then we have the value 33 repeated 9 times, and then we have the value 34 repeated 8 times, and the value 35 repeated 11 times. So in a sense, you could do like, okay, 35 plus 35 plus 35 plus 31, and so on, so on, so on, like all the amount of times that the frequency gives you. But that could be made simpler, as I mentioned earlier, because the mean is the sum of the value of x multiplied times the frequency, and that divided over the sum of the frequencies. So this would be okay. In this case, we will have the mean x to be the value 31 multiplied times 5. And then we will be adding the value 32 multiplied times 7. This is what this means. This means the value of x multiplied times the frequency plus the value of x multiplied times the frequency. Then we would say, okay, the 33 we multiplied times 9, the 34 we multiplied times 8. Let me erase this. 34 we multiplied times 8, and then the 35 we multiply times 11, and then everything here we're going to divide it over 5 plus 7 plus 9 plus 8 plus 11. So therefore we have the operation that we would need to make. This will give you 33.325. That will be the exact solution. In case you're told to round it, then, well, you can round it. But you see that this is not a complex thing to use. It's like, okay, value times frequency plus value times frequency, and so on, and so on, and so on. So this is like to begin with working with the mean. Another thing that we're going to be doing a lot throughout the mathematics is to combine set of data, and this combined set of data, we're going to see what happens with the mean in very different ways. So, for example, here we have the thing that I want to mark here is that if you have two sets of data, in this case we have 1, 2, 3, 4, and then we combine it with 4, 5, 6, we get this data sets 1, 2, 3, 4, 4, 5, 6. And the mean that we get for the new value is not going to be the mean of these two values. That is clear, I believe, for you. You can try it out for yourself, but you can find it here. So we need to consider a very beautiful formula that we should have around here. I didn't write it here, so this is what we're going to be doing. In general, we're going to say that the mean of x plus y is equal to the sum of the x values plus the sum of the y values over the amount of values for x plus the amount of values for y. This is like the general formula. So let's say that for this example that we're going to see, we're going to look at it. We're going to take a look at this. We're going to say, okay, we have a large bag of sweets that has 72 sweets. So we're going to call this 72. It's going to be the number for x. And it has a total mass of 854.4. This is going to be the sum of x. And then we have 24 sweets. This is going to be the number for y, and it has a total mass of 282.8. This is going to be the sum of y, and we're asked to find the mean mass. The mean mass is exactly the x plus y bar. So how does this work? Well, it's quite straightforward. It's x plus y. We have the sum of x, we have it there, is 852.4. We are going to add the sum of y, that is 282.4.8. And then we're going to divide this over 72 plus 24. This is just the sum of everything divided over the sum of the amounts of things that we have. It's quite straightforward. We go into the math and we get an average of 11.825 grams. That will be the mean mass for these sweets that we have here. So again, quite straightforward. Once you get to the formula, you can look at it in the web page that I have the link in the description. You can go to provide statistics in the left menu, and then you access the part on measures of central tendency. You will have more exercises on how to work with the mean of combined data. It is quite straightforward, and you may eventually need to solve some things out, but it's actually not that complicated once you get to the hang of the formula. So far, we're working with this, and now we're going to take a look at what happens when we have grouped frequency table. This could be either in a table, it could be in a histogram, it could be in a cumulative frequency graph. We don't have the raw data, so we cannot find the exact mean. So in this case, we're going to be working with making estimations and how to make estimations. If we have data to be into classes, we're going to be using the mid values. And remember the importance of rounding here. As usual, go to the video on histograms if you don't remember what I'm talking about when rounding. It's something that may occur in these cases. And again, it's the very same formula that we were working earlier. It's just that we are using the mid values for the value of x. So let's take a look at another example that we can see here. This is quite a complete example if you want it, because we have coconuts packed into 75 crates. They all include 40 coconuts that have a similar size. And then we are told some information. I'm going to try to write it down. We have 46 crates that have a mass up to 20, but not including 25. So we can write it maybe something like this. Let's call the value for m. So this would be greater or equal than 20 or less than 25. This would have a frequency of 46. Then we have a mass of 25 up to and not including 40. So we have here this thing, this interval where we have 22 crates. And then finally we have 40 up to but not including 54. We have a frequency, these are the values of the frequencies, frequency of 7. So all of this add up to 75. If I'm not wrong, this would be 68 and then plus 7, 75. Very good. And we're going to see if we can make an estimation of the mean mass of the coconut. So okay, let's begin by trying to find the mid values. Remember that the mid value is the average of the boundaries of the class. So in this case, it will be 20 plus 25 over 2. This would be, I'm going to call it here the mid value. This is going to be 22.5. Then we're going to have a 32.5. And then here we're going to have a 47. So essentially, the mean mass is going to be 22.5 times 46 plus 32.5 times 22 plus 47 times 7. That's divided over 46 plus 22 plus 7, that we know that is 75. So we make the operation and then we would say that the average of the mass of each crate is 27 times 72 kilograms. Again, if you want to look at this into depth, you can find everything developed on my web page, but it's just that operation is frequency times mid value plus frequency times mid value plus frequency times mid value divided over the sum of the frequencies. And then for the second part, you have to estimate the mean mass of a coconut, and you know that each crate has 40 coconuts. So for parts B, you would be just saying, okay, if this is the mean mass of one crate, then we're going to divide this over 40, and we can get that if we are assuming that they are all similar size and everything, this would be 693 kilograms for one coconut. Okay, this is just like let's say a fair assumption on the data that we have. Clearly we cannot have the exact data here, but we can make a good assumption with this. Again, if you want to look at more exercises, you can go to my webpage where you can find more on this. And then finally, the last thing we're going to be doing is we're going to look at coded data. Coded data is a very important thing on A-levels. It appears quite a lot, and it may appear both as a theoretical and as a practical exercise, so you may need to practice this a lot. Coding means transforming values, means adding a positive or a negative constant that it was originally made for that calculations are easier to be made manually. For example, we can code so that the mean becomes 0, so that calculations are easier. That is something that we can do. And well, we will do this with central tendency. We're going to do this with variation, and we're going to do this then when we get to the normal distribution. That is the last topic on probability statistics. We're going to be doing this again. So this is something that you may get used to doing. This formula may be a bit confusing, but I want to emphasize that this is not that difficult to understand, because think about it. If you are given a set of data x that has a mean over bar x, and then we take a value y that is the value of x, and then we subtract a constant b, then the new mean is just the old mean minus b, because every value has been subtracted a value b, So then the new mean is just subtracting that. It's not that complicated. It's like, okay, imagine that we have the average of ages. That's what we're going to see in the following example. The average of ages of some students today is 17 years old. Then 3 years ago, it was 14 years old because each age is subtracted 3. So it doesn't change that much. It's like, okay, just subtracting the same. So we're going to see this example so that we can look at it more completely. We have here the exercise where we're giving that. We're going to call B the age of a boy, and we're going to call it exact age so that we can use decimals here. And for a girl, we're going to call it G. And then we are told that 5 years ago, the sum of the ages of 10 boys was 127. So from here, we are told two things. We are told that the number of boys is 10, and we're told that the sum of the ages of the boys 5 years ago is 127. I'm omitting the point no for now. And then we're told that in exactly 5 years' time, the sum of the ages of 15 girls, so we have that there are 15 girls, this is 15, the number of G, the sum of the girls' ages, so it's going to be the sum, the girl age in 5 years, so it's going to be G plus 5, this is going to be 351. So we had to find the mean age of the boys, of the girls, and then all of them combined. Now think about this. I'm going to start with the boys. For the boys, the sum of b minus 5 is the first boy minus 5 plus the second boy minus 5 plus the third boy minus 5, and so on and so on and so on until we get to the last boy minus 5. So if you think about it, what we're just doing here is we are adding all the ages of the boys, and then we are subtracting 5 10 times, right? Because it's 1 for each boy. But this here is the value that we're getting here. This is 127. So from here, we can get the sum of the boys, because the sum of the boys minus 50 is going to be equal to 127. So from there, we can solve that the sum of the ages of the boys is 177. Now, the average, I'm going to write this down over here. The sum of the boys is 177. And then just we know that the average, the mean age of the boys is just the sum, the average of the boys is just the sum of B over the total 10. And now this is 177 divided over 10 is going to be 17.5 as a mean value. Likewise, we can do the very same thing with the girls, because again, we can say, okay, well, the sum of G plus 5, this is our G, is going to be the first girl plus 5 plus the second girl's age plus 5 plus so on and so on and so on until we get to the 15th girl plus 5. So again, this is the sum of the ages of the girls, and then we're adding 5 15 times. So, and this is equal to 351. So we can get that the sum of G is going to be equal to 276. From there, I'm going to write that down here, that the sum of G is 276, and we can find the mean value for the girls. The mean value for the girls, that is again G bar 276 divided over 15, that will give us 18.4. So there we have the mean for the boys and the mean for the girls' age. Finally, in order to find the boys and girls mean combined, we're going to use the formula that we used earlier. We're going to say, okay, yeah, the mean of boys and girls is the sum of the boys plus the sum of the girls over the number of boys plus the number of girls. It's just that. And then we are going to plug in everything we have. We have the number, the sum of boys, we have the sum of girls, the number of boys, the numbers of girls, and this will give us 18.12. That will be the final answer. You can take some minutes to work on it. And if you're having some problems, you can go to my webpage and you will find the step-by-step solution. Finally, before we finish with this video, I want to go over some of the advantages and disadvantages of the mean. The first one is that every value is taken into account. And as you will learn later, we use the mean in other calculations. It is something that people understand. It's like if you want to present it, it's simple to understand. And we can also use it to find the sum of totals. That is something that we have been doing and we may need to do in other contexts as well. The disadvantages are mainly two. The first one is that if we don't know the total, all of the values, we cannot find it exactly, and in some cases we may need to estimate it. And then finally, that if we have extreme values, is going to be affected. So that's something that may happen, and we need to. It's not that we're not going to use it. It's just that we need to consider it into our analysis. So I hope that this video has been useful. I know that there is quite a long video for us to deal with, but it has a lot of parts. So again, as usual, if you have any questions, you can leave them in the comment section. I will try to address them as soon as possible. And well, thank you all for watching.